Our lesson today is lesson 64, identifying, writing, and graphing inverse variation. Before we really begin, I'd like to talk about what the word implies mean. I have written up here direct variation implies, and I have something hidden there. And then I have inverse variation implies, and I have something hidden there. There's something hidden under here. But what does the word imply mean? Well, it means to suggest by logical necessity, or suggest without stating, or to hint, or to insinuate. So I have developed a little mnemonic to help me remember what direct variation is. And notice I have the DI in the word direct underlined there. And direct variation implies division. And notice that division starts with a DI. So direct variation implies division, whereas inverse variation would imply, what's the opposite of division? Multiplication. So there's really no way of telling or getting a mnemonic for the inverse variation implying multiplication. So I just use the direct variation implies division, and the other variation, inverse, implies multiplication. And we're going to be talking about variation between two or more variables. So we could have 3 variables or 4 variables in one problem, but for now we'll just have 2. But look at the next screen here, and we set our you'll notice in the textbook they have mentioned a K in when they're talking about variables or variation, and K is a constant. K is a constant in this designation. So, and the X and Y are the variables. So here we have X and Y, and they're what? They're divided. So they're on the same side of the equal sign, and what's taking place here? Division. So this would indicate direct variation. Excuse me. And the quotient of one variable over the other is equal to a constant. Now here's the way inverse variation would be set up. It's multiplication. X times y is equal to the constant. Now I could get the y on the other side of the equation by dividing both sides of the equation by y. So then I would have the y's would cancel here, and I'd have x is equal to k over y. Well, now I have division here, but the division is not between the variables. It's between one of the variables and the constant. So what I need to do is get the variables on the same side of the equation so that I can tell whether it's multiplication or whether it's division. And if it's multiplication, then that implies inverse variation. Inverse variation. Okay, let's look at practice problem on page 421. Tell whether the relationships are inverse or direct in A and B here. Well, they're not on the same side of the equation here, so what we need to do is we need to divide both sides by y, and here the y's would cancel, and I would have 4 is equal to x over y. Well, what's happening between the variables here? Division. So A would be direct variation, and what's happening between the variables here? The variables here are being multiplied, so that is an inverse variation. Okay, and the C part of the practice there, it says if y varies inversely as x and y, as x, if y varies inversely as x, and y is equal to 3.5 when x is equal to 20, find x when y equals 10. Well, now what kind of variation is it? It's inverse variation. So inverse variation implies multiplication. So y varies inversely, y times x. That's kind of our map, if you want to call it that. So y times x. Well, when y is 3.5, then x was 20. And what did we say that was equal to? That was equal to a constant. Well, a constant, if this product is equal to a constant, then any value of y times the corresponding value of x will be equal to the same constant. So we could say that 3.5 times 20 is equal to, and then the next scenario, find x when y is 10. Well, x times 10, and just simply solve this equation for x. Okay, we would do that by dividing both sides by 10. The 10s would cancel here, and we would get x is equal to, 10 would cancel into 22 times, so x would be 7. Okay, the D part there says write inverse variation relating x and y when x is equal to 8, y is equal to 1/2, then graph the relationship. Okay, so it's inverse variation, so our map is x times y. That's our map. Okay, so we're going to use our numbers here. So we've got 8 times 1/2, and that's equal to a constant, right? It's equal to a constant. Well, what is that constant in this case? Well, that constant is equal to 4. So going back to our map, we could say that x times y in this scenario is equal to 4. And then we could, in order to graph this, we need to solve this equation here for y. So we would divide both sides by x, and the x would cancel here, and we would have y is equal to 4 over x. Now let's graph that. I think we can graph that. Okay, here's a graphing calculator. We can do that by going to y equal, and we want, what did we say it was? It was 4 over x. Okay, so 4 divided by our x, and we use the xt theta button, and we could graph that. And notice we get two pieces of graph, one here and one here. Okay, so we've just graphed that. Okay, so let's move along. Okay, Sierra, this is the E part. Sierra found an inverse relationship, and I think that's between her hourly rate and the number of hours she must work to earn a certain amount of money, or a set amount of money. And it says if she works 7 hours for $8 an hour, and that's inverse, so we need to multiply. So what are we going to call these? We're going to call these her hourly rate. Let's call it rate times how much she earns, or salary. Okay, so rate times salary, multiplication, and that's equal to a constant, or that's equal to our map. Okay, so she found that when she worked 7 hours, let's see, we got a rate times time. I'm sorry, it's time, rate times time right here. Rate times time. She worked 7 hours, and for $8 an hour was her rate, and that was equal to, how long must she work? So how much time does she have to work making $10 an hour to make the same amount of money? Well, we simply multiply this and get 56 is equal to 10t, and divide both sides by 10. So t would be equal to, I believe, 5.6 hours. So after watching the video, please send the answers to problems 3 and 4. The homework assignment for tomorrow in class will be problems 1 through 12, 15 through 19, and 24 through 27. It's also suggested that you work 6 to 8 of the above problems before class in order that you be able to finish the assignment in class tomorrow.